Hello friends, welcome to the next lecture. In this lecture, we are going to learn about what are the different digital signature schemes available to implement the signature process. So to begin with, the signature, the digital signature is considered as a physical part of the document, and while forgery is certainly possible, it is difficult to do so very convincingly. It is very important to have such signatures to be a part of the document to prevent it from forging. Trying to mimic a handwritten signature in a digital medium leads to difficulty since cut and paste operations can be used to create a perfect forgery. Thus, we need to have a way of signing messages digitally which is functionally equivalent to a physical signature as we do with our hands, but which is at least as resistant to forgery as its physical counterpart is. Schemes which provide this functionality are called as digital signature schemes. Now, digital signature scheme will have two main components, a private signing algorithm and a public verification algorithm. A private signing algorithm which permits a user to securely sign a message, and a public verification algorithm which permits anyone to verify the signature and its authenticity. The signing algorithm needs to bind a signature to a message in such a way that the signature cannot be pulled out and used to sign another document, or have the original message modified and the signature remains valid. For practical reasons, it would be then necessary for both algorithms to be relatively fast, and if small computers such as smart cards are to be used, the algorithms cannot be too computationally complex. So, whatever the schemes, whatever the algorithms, whatever the digital signature methodologies have to be implemented, they have to be practical reasons, and it should be necessary for both the algorithms that they should be relatively fast, and it should be relatively and computationally it shouldn't be complex. So what all algorithms are need to be used, they should be relatively easy to implement as the signature algorithms. Digital signature schemes are techniques to assure an entity's acknowledgement of having seen a certain digital message. Typically, an entity has a private key and a corresponding public key that is tied to the entity's name. And guys, whenever the collection needs to be taken place of these public key and the private keys, and the key pairs needs to be properly saved in an infrastructure, and that infrastructure is here considered as the public key infrastructure, wherein the maintenance, the allotting of the public keys, maintaining of the public keys, everything takes place in the proper manner, and that's why a name is given as public key infrastructure. The entity generates a string called signature, which depends on the message to send, and his private key depends on the message to sign and his private key. That means a signature, when is to be implemented, the public key infrastructure plays a very important role, wherein the entities names are tied to the corresponding public key of that particular entity, and the messages which needs to be signed should have their private keys also. So every detail of a particular entity is being then stored in the public key infrastructure in a secured manner. The digital signature schemes, the fact that the entity acknowledged, that is that he has signed, or a particular sender is sending a message, then that particular sender has signed the message, can be verified by the receiver who is receiving that particular message. So the fact that entity acknowledged, that is he signed the message, can be verified by anyone using the entity's public key, the message and the signature. That means that message and the signature, whenever it is received at the receiver's end, that should be verified at the receiver's end, and for verifying it, the entity's public key should be available with the receiver. It do provides two things, that is data authentication and non-repudiation. Data authentication and signature schemes are sometimes distinguished in the sense that in the later, verification can be done by anyone at any time after the generation of signature. And due to this property, the digital signature schemes achieves, right? That means whenever we are signing any document and it is being received at the receiver's end, that receiver should be known, or that receiver should get that confirmation that whatever the message I have received is properly signed and is properly encrypted by the sender, and whatever I have received is the original content. Non-repudiation property, that is, a signer cannot later deny the fact of signing it. That means whoever the receiver is and has received the message from the sender, and if sender has signed that particular message, then the sender cannot deny the fact of signing that particular message. Then that means that sender cannot deny the fact of implementing the digital signature either by using its private key or by using its public key. Whatever the signer, whatever the sender has used, that particular sender cannot deny the fact. And it may be the possibility that receiver has received it, and then receiver also cannot deny the fact of receiving the signed message from a particular sender. So the digital signature schemes do verify or do implement these two terminologies of data authentication and the non-repudiation also. Here are some of the examples of digital signature schemes that we have to learn. That is the RSA digital signature scheme, the Elgamal digital signature scheme, Raven digital signature scheme, Schnorr digital signature scheme, digital signature standards, and the Nyberg-Ruppel signature scheme. Out of this, we do have to learn about RSA, Elgamal, Schnorr, and digital signature standard. Under the topic of digital signature standard, we also be learning the digital signature algorithms which are then implemented for implementation of the digital signature standards. Thank you guys. I just hope that you might have got the concept of what the digital signature is and why it is implemented. Keep listening, keep learning. Thank you.